We are going to be looking at rearranging mixed questions, and then there's an exercise at the end of this video. So let's look at this example here. We've got the same question twice. I'm going to show you two ways of doing this. If you can already remember how to do it, have a go. You can either expand first or you can divide first as your first step. Both methods are equally correct, but one might be slightly easier. So I'm going to do the expansion first. So let's say you wanted to expand the brackets. Well, you would get 3x plus 6 equals 21. I would then have to take away 6, take away 6. So I get 3x equals 21, take away 6 is 15. And then I'm going to divide by 3, divide by 3. So I get x equals 15 over 3, which is 5. The second way I could have done the same question is I could have divided by 3 first. Because 3 brackets x plus 2 means 3 lots of x plus 2. So we divide by 3, the 3's cancel out. So I get x plus 2 equals 21 over 3 is 7. And then I'm going to take away 2, take away 2. So x equals 7 minus 2, which is 5. So you get the same answer. Both methods give you the same answer. Now, dividing turned out to be more efficient this time. It does depend on the question, and with practice you'll be able to figure out which method to use. They're both relatively sensible. However, if you were to get a question like this on the right hand side, you would have to consider what to do first. You can still do both methods, expand or divide first, but let's see what happens when you divide. You're going to see that dividing in this case doesn't really lend itself to make this any easier. So have a think why that might be. You might spot it straight after the first step. So let's divide by 3, divide by 3. Now you have 3's cancel out. X plus 2 equals 17 over 3. And then I'm going to take away 2, take away 2. So x equals 17 over 3. And then I have to take away 2 from that. Now mathematically this is perfectly correct. I need to work this out just to finish this off. But it's going to be a bit easier if instead of dividing, you expanded it as a first step. So that will avoid us having to deal with the fractions at the end. Just makes it a little bit easier. So let's have a go with that. Let's expand first. So we're going to get 3x plus 6 equals 17. I'm going to take away 6, take away 6. So 3x equals 11. And then divide by 3, divide by 3. So x equals 11 over 3. So the fractions calculation from the previous question would have given you 11 over 3 once we would have added the fractions up. But in this case, we didn't need to do that because it was more efficient to do the expansion first. So just be aware, the method you choose can make a difference in how difficult the question is. Okay, have a go with both of these. Try to expand first here and try to divide first here, and then I'm going to go through both methods. Okay, pause the video if you need more time. So let's try expansion. So I'm going to get 3x plus 6 equals y. Now I want to solve for x, so I'm going to take away 6, take away 6. So I get 3x equals y minus 6. And then I'm going to divide by 3, divide by 3. So x equals y minus 6 all over 3. I can split this into two different fractions because there's just a single number in the denominator. But I'm going to leave it like this. This is fine as a final answer. Now let's try to see what happens when we divide by 3 first. So you're going to divide by 3, divide by 3. So that becomes x plus 2 equals y over 3. And then I'm going to take away 2, take away 2. So I'm left with x equals y over 3, take away 2. Now if you write 2 as a fraction, it becomes 2 over 1. Now 2 over 1, just on the side here, I'm going to write 2 over 1 is actually equal to 6 over 3. 2 over 1 is just 2, 6 divided by 3 is also 2. So we can replace 2 over 1 with 6 over 3. You're going to see why in a second. And then I can just combine this. Y thirds take away 6 thirds is the same as y minus 6 thirds. Now if I go back again and change this back to a half, 2 over 1 or just 2, I'm allowed to leave my answer like this. So the two things I put in boxes are just different ways of representing the same thing. They are both correct as final answers. Technically so is this, obviously that's the same as what I have on the left. But both of these look different, but they are equivalent and they are both correct final answers. So just be aware of different representations, especially when you're rearranging harder equations. Okay, so have a go with making P the subject of these two equations, and then I'm going to show you how to do it in 3, 2, 1. So now we can decide what we want to do here. We either expand or divide. There isn't really a strong preference. I'm going to decide to divide first, and there's no special reason for that. So I'm going to divide by 2, divide by 2. So I get P minus 3 equals m over 2, because the 2's cancel out. And then I'm going to add 3. Add 3. So this becomes P, that's a 0 pair, so that cancels out, is equal to m over 2 plus 3. You can leave your answer like that, or you can turn this into a fraction and then add it up, but we're not going to do that. We're just going to leave it because we're allowed to do that. And the question on the right, now we can divide or expand. I think dividing, let's do expansion in this case, expansion, so we can try the other method. This will be 8p, take away 4 times 3 is 12, is equal to 5y. We want to isolate p, so I'm going to add 12 to both sides. So that gives me 8p, that's a 0 pair, is equal to 5y plus 12. And then I'm going to divide by 8, divide by 8. So p equals 5y plus 12 all over 8. That is your final answer. Hope that was useful. Let's try some more practice with some harder questions. So here we've got a fraction in our equation, and we are trying to isolate z. We want z to be the subject. So have a go if you're confident with it, otherwise I'm going to show you how to do it, and then there's a practice question. So in this case, if I want to isolate z, first thing that would make sense is if I add r to both sides. So this becomes 5 plus r equals z over 3. Now if I want z to be by itself, I'm going to have to multiply both sides by 3, multiply the left hand side also by 3. So this becomes 15 plus 3r is equal to, now the 3's cancel out there, so it's just going to be z, and that is your final answer. Have a go with the question on the right, see how you do, and then I'm going to show you the answer in 3, 2, 1. Okay, so I want to isolate z, so I'm going to get rid of m first by doing the 0 pair on the left hand side and the right hand side. So 7 minus m equals z over 4. That's a 0 pair there. And then we're going to multiply the right hand side by 4 to get rid of the denominator, multiply the left hand side by 4. So this becomes 4 times 7, so that's 28, minus 4m equals, the 4's cancel out there, so it's just going to be z. There's your answer. Alright, some more practice for you to do try both questions and then I'm going to go through the examples. Okay, we're getting to some tricky looking questions here. The skills haven't changed. We're still using the same skills, doing the same thing on the left hand side and right hand side to maintain equality. So I want to isolate y. I need to get rid of the 10, the 3 and the 5. Let's start by subtracting 10 from both sides. So this becomes 5x minus 10. That's a 0 pair. That's equal to 5y over 3. I'm now going to multiply both sides of the equation by 3. So I get 15x minus 30, because we've expanded the brackets using the distributive law, is equal to, well, these 3's cancel out, so we get 5y. Then my next step is I'm going to divide everything by 5 on the right hand side and the left hand side. Now this is convenient because 15x and 30, you can divide both of them by 5. You can get 3x minus 6, because 30 divided by 5 is 6, is equal to, and the 5's cancel out here, is equal to y. There's your answer. And then the one on the right, pause the video if you haven't done it. We want to isolate y, so let's take away m from both sides. We're going to get 7 minus m equals 4y over 3. We're going to have to multiply both sides by 3 to get rid of the denominator on the right hand side. So this becomes 3 times 7 is 21 minus 3m equals 4y. We're going to isolate y, so we're going to divide by 4. So divide by 4, divide by 4. Now these two numbers, 21 and negative 3m, they don't divide by 4, so we leave our answer as is. So this is going to be written as 21 minus 3m all over 4 equals y. That's your final answer. Okay, some more examples. Have a go with both of these if you can. Pause the video. Okay, so what we want to do here is isolate m. So step 1 would be, I would say, let's get rid of the denominator. We're going to multiply by 3. Multiply by 3. 3 times 5p is 15p. Is equal to, these 3's cancel out, so 7 plus m. We want to isolate m, so we're going to take away 7 from the right hand side, take away 7 from the left hand side. So this gives us 15p minus 7 equals m. That's it, that's our answer. We have made m the subject. Okay, next example. Pause the video if you haven't tried this. You must try this. This is going to be the last example. We've got 7 equals y minus 12t over 10, and we want to isolate y, or make y the subject. So we're going to need to multiply by 10, and then we're going to add 12t. Let's do the multiplication first. So multiply the left hand side by 10, multiply the right hand side by 10. So those are going to cancel out. So 70 equals y minus 12t. And I'm going to add 12t, add 12t. So this becomes 70 plus 12t equals y, and that is your final answer. Okay, so the next video in this playlist is going to have this exercise ready for you to work through along with fully worked solutions. Pause the video and have a go with these questions, all of them, really important. And the next video is going to work through all of these. I'll see you in that video. Smash the like button. Hope that was useful.